Being able to measure an angle accurately is a really key skill. It's really important for pie charts, it's really important for loci, and it's really important for construction. So the first thing I'm going to do is teach you a really simplistic way to measure angles. The first thing I'm going to do is draw one. And then, if you see an angle and you're asked to measure it in an exam, I would suggest to you that you take a coloured pen and you just very, very carefully draw an identical line over the top. So just make one of your lines slightly more colourful, and that will help you keep track of what you're doing. Now, unfortunately, that green has not showed up because I'm being silly and using an inappropriate colour. So I'm just going to put this one over the top. Okay? So now what I'm going to do is I'm going to take my protractor, which only measures 180 degrees, and I'm going to use my coloured line to help me decide which zero to use, because there's two scales here. There's one that goes clockwise, like this, and there's anti-clockwise here, which goes the other way. Okay? Now, the first thing you need to do is find your crosshairs on your protractor, and that's where your 90 degree line meets your 0 or 180 line. And we're going to place that over the point where our two lines meet. Then what we're going to do is twist it until one of our zeros is directly over the top of our coloured line. Now, whichever zero is touching our line is the scale we use. So we're not going to use the outside one, we're going to use the inside one, which is going anti-clockwise. So now we're going to see how far our second line has travelled in degrees from our first line. So if they were on top of each other, this one's moved all the way around to here. So our measurement is not quite 90 degrees. Can you see that our large pip for 90 is just slightly after our line? So we know that our angle should be less than 90. So it would be an acute angle. It's very close to 90 though. Now what you need to do, if you know it's less than 90, is just see how many away yours is, and mine is exactly 1 degree away from 90. So that means that it's 89 degrees in total. So that's the largest whole number acute angle that you could have before you have a right angle. And I'm going to show that it's not exactly a right angle by putting part of a circle, which is called an arc, here rather than a square. And a square here means that it's exactly a right angle. So if you drew a right angle, you would draw a square, and that means that it's 90. But because this looks like a right angle, but it's not, I need to show another mathematician that by using this angle here, and that shows a mathematician that although it looks like 90, isn't actually 90 because I haven't used the 90 symbol. The measuring of angles that people find hardest is a reflex angle. Now, a reflex angle is one that's further than 180 degrees. So here, we know that it's further than 180 because from here to here is 180 degrees, and all the way around to our actual line is greater than that. So we know it's a reflex angle because we've flexed further than 180 degrees or a straight line. I'm going to show you the way that I like to do this, and then I'll show you the other way as well. Now, I know that if I was a person and I was facing this position, if I spun all the way around to end up facing the same position as I started, I would have travelled 360 degrees. So the angle around a point would be 360 degrees. There's only two angles here, one this side and the smaller one this side. Now actually it's much easier to measure the smaller one and then remove it from 360 because whatever is removed from here just leaves me with the one I actually want. So I'm going to use the same method as I showed you before. I'm going to draw a line down over the top of one of my lines. I'm going to put my cross hatchings in the middle, line up my zero, and then I'm going to measure 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, sorry, 110, 120, that's 125 exactly. So I know that this is 125 degrees. So that means that this section must be 360 minus 125. I can't take 5 from 0, so I'm going to borrow a 10, and this becomes 5 tens now. So we've got 10 minus 5 is 5, 2 from 5 is 3, and 1 from 3 is 2. So I know now that my actual reflex angle that I'm interested in measuring is 235. So that's called a subtraction method. Now I'm going to show you the addition method instead. So let's draw another line. And I want this angle here. Now, the other method isn't based on 360, it's actually based on 180 plus a little bit extra. So what I'm going to do is pick one of my lines, and I'm just going to extend it past the point where my normal two lines would meet, and I'm just going to draw a dotted line on so my examiner understands the method I'm using. Now I know from here to here that I have 180 degrees because this has twisted and created a perfect straight line. Now what I need to do is just work out what the extra bit is on top. So I'm going to put my crosshairs in the middle of where my two lines meet. I'm going to run my 0 down my dashed line this time because it would be my coloured line, and I'm going to measure how far I've travelled, so 10, 20, 30, 40, 50, 65 degrees, and I'm just going to label it here. Now the examiner can see that I know that this is worth 180 and I know that this is worth 65, and I'm going to add them. So if you ever panic and feel that you're not confident with subtraction, you can use this method instead. You break the angle down into a straight line and add on whatever extra you have over the top of a straight line. So 0 plus 5 is 5, 8 plus 6 is 14, carry the 1, and that's 200, whoops, keep writing there, 245 degrees. So this angle here is 10 degrees less than this angle, and I would just label it to the examiner that that is 245 degrees in total so that he understands what I'm working out. Job done.